Have you ever wondered what might have been? What if you had turned left instead of right this morning, or chosen a different breakfast cereal? What if you had pursued that childhood dream of becoming an astronaut or a rock star? These what-if scenarios are part of the human experience, little thought experiments we run in our minds. The idea of parallel universes takes this familiar game of what if and elevates it to a cosmic scale, suggesting that every possible outcome of every decision you've ever made might be playing out for real, right now, in a universe existing alongside our own. This isn't just the stuff of science fiction, though it has certainly fueled some of the greatest stories ever told. The concept of a multiverse has actually emerged from the cutting edge of theoretical physics. So let's embark on a journey into this grand what-if machine. We'll explore the scientific theories that suggest these other worlds might be real, peeling back the layers of cosmology and quantum physics in an accessible way. To get our heads around this, let's start with a simple analogy. Think of our universe as a single slice of bread in an infinitely long loaf. Our slice has its own unique pattern of seeds and air pockets, our stars, galaxies, and physical laws. The theory of the multiverse suggests that there are other slices, stacked right next to ours, both before and after. Each slice is a complete universe in its own right, potentially with its own unique features. Let's use another fun example. Picture a giant apartment building. Our universe is just one apartment in this colossal structure. We can decorate our apartment however we like, following the rules of physics that apply within our walls. But next door, in another apartment, the rules might be slightly different. Maybe their gravity is a bit stronger, making it harder to get off the sofa. In another apartment down the hall, maybe the speed of light is slower. One of the most straightforward yet mind-boggling multiverse theories comes from the sheer incomprehensible size of space. It's called the Quilted Multiverse, and it doesn't even require any fancy new physics. Think about it like shuffling a deck of cards. There's a huge number of possible shuffles, but it's not an infinite number. Sooner or later, if you shuffle for long enough, the exact same order of cards is bound to repeat. If space goes on forever, then eventually, out there in the unimaginable distance, there must be another region of space where the particles are arranged in the exact same way as they are here. There would be another Earth, another you, another me. This means there are universes that are almost identical to ours, but with one tiny difference. For example, there's a universe where everything is the same, except you chose to wear a blue shirt today instead of a red one. Another leading theory for the multiverse comes from our understanding of the universe's earliest moments. It's called the Inflationary Multiverse, and it's a direct consequence of the theory of cosmic inflation. Think of it like a pot of water boiling. As the water boils, it creates steam bubbles. In this analogy, the boiling water is the inflating space, and our universe is just one of the bubbles that formed and then broke away from the main boiling region. According to the theory of eternal inflation, the water of space is always boiling, constantly spawning new bubble universes. Each bubble expands and cools to form a complete universe with its own matter, galaxies, and perhaps even its own unique set of physical laws. But in this infinite foam of bubbles, some would, by pure chance, have the just right conditions for life to emerge. This is known as the anthropic principle. It elegantly explains why our universe seems so perfectly fine-tuned for our existence. Perhaps the most bizarre and fascinating multiverse theory comes not from the vastness of space, but from the weirdness of the very small. It's called the many worlds interpretation of quantum mechanics. In the 1950s, a physicist named Hugh Everett III proposed a radical solution. He suggested that every time a quantum measurement is made, the universe itself splits into multiple branches. In each branch, one of the possible outcomes becomes real. This theory implies that there is a version of you that made every single choice you ever could have made. Every fork in the road, no matter how small, leads to a new branch in the timeline, creating a new universe. Unlike the other multiverse theories where parallel worlds are separated by vast distances, the many worlds are thought to exist all around us, in a different dimension of reality that we cannot access. It's a staggering thought. An infinite number of alternate histories are being written with every passing nanosecond. The idea of traveling to a parallel universe is, honestly, a cornerstone of science fiction. A fantasy of stepping through a shimmering portal into a world that's both familiar and, well, strangely alien. If we could somehow bridge the gap, the experience would be profoundly disorienting. Imagine arriving in a universe that's almost identical to ours, but with these subtle differences. The sky might be a slightly different shade of blue, the taste of water might be off. Furthermore, what if you encountered another version of yourself? This doppelganger would be a person with their own life, their own memories, and their own consciousness. The psychological impact of meeting another you who made different life choices would be staggering. Unfortunately, despite all the exciting possibilities, current scientific theories suggest that travel between universes is likely impossible. So, for now, the ultimate road trip remains firmly in the realm of imagination. Long before physicists started writing equations about the multiverse, storytellers were already exploring its mind-bending possibilities. One of the most classic examples is C.S. Lewis's Chronicles of Narnia, where children stumble through a wardrobe into a magical kingdom. In more recent times, pop culture has really embraced the more scientific and complex aspects of the multiverse. The Marvel Cinematic Universe has made it a central plot point, with stories showing different versions of beloved characters interacting. Television has also dived deep into the concept. Shows like Fringe built their entire narrative around a war between two parallel universes, really focusing on the doppelgangers of its main characters and the moral complexities of sacrificing one world to save another. These stories do more than just entertain us. They act as a cultural sounding board for these complex scientific ideas. By exploring these questions through characters we care about, pop culture helps us grapple with the philosophical weight of the multiverse. Beyond just being a fascinating concept, the multiverse might actually be a powerful tool for solving some of the biggest puzzles in physics and cosmology. One of the most significant of these is the fine-tuning problem. The multiverse provides a pretty simple and elegant answer. It's not luck. It's statistics. If there are countless universes, each with its own randomly assigned set of physical laws and constants, then it's really not surprising that we find ourselves in one that's perfectly suited for us. The many worlds theory, by suggesting that all possibilities actually happen in their own separate universes, removes the need for a mysterious collapse of the wave function. It suggests that the underlying laws of quantum mechanics are simple and universal. Finally, the multiverse could even shed light on the nature of dark energy. Once again, the multiverse turns a perplexing problem into an observational selection effect. The journey through the multiverse is one that, honestly, stretches the imagination to its absolute limits. We've traveled from the simple idea of a cosmic loaf of bread to the mind-shattering concept of a universe splitting into infinite copies with every passing moment. While we currently have no direct, testable evidence for these other worlds, the fact that multiple independent lines of scientific inquiry all point towards a multiverse makes it a concept that we really have to take seriously. It might just be the next great revolution in our understanding of the cosmos. The idea that our entire observable universe might be just one bubble in a cosmic foam is a powerful dose of humility. At the same time, it fills the cosmos with a sense of boundless wonder and possibility. If the many worlds theory is correct, then every decision we make creates new realities. This doesn't diminish the importance of our choices. Actually, it imbues them with a kind of cosmic significance. Our life is not just one possibility out of many. It's the reality that this specific version of us gets to live, and that makes it precious. It transforms the night sky from a collection of distant lights into a curtain behind which an infinite number of other dramas may be unfolding. The story of our cosmos may just be one chapter in an infinite library of tales, and honestly, that is a truly magnificent thought.